In this video, we're going to take a look at solving linear equations and inequalities. This is one of the key concepts that you need to master in any algebra course. So I would say that this is a very important topic, and make sure that you are very good at it. Let's start with an example like this. 3 parentheses 2 minus 3p equals 42. Our goal in this problem, if we're solving this linear equation, and the reason it's linear is because p is of the first degree, meaning it has an exponent of 1. So if we're going to solve this linear equation, we need to get p by itself. We have to figure out what value of p makes this equation true. And normally you would want to use the order of operations, take care of anything inside the parentheses, so multiplication, then subtraction, then do the multiplication on the outside, and you should get your answer. But when we are solving for a variable, we want to go pretty much in reverse. We want to first start with any random addition or subtraction outside of parentheses, which we have none this time. Then we want to get rid of any multiplication outside of parentheses. So I have a 3 here, it's multiplying this parentheses, and I need to get rid of it, and you use the inverse operation. So instead of multiplying by 3, I'm going to divide by 3. That cancels out my 3, and I now have 2 minus 3p. I don't need the parentheses anymore because nothing is affecting it on the outside. 2 minus 3p equals 14. Our goal is still to get p by itself, so now that we don't have the parentheses, we still want to go in reverse order of our order of operations. So get rid of any addition or subtraction first that is not affecting the p, and we have to get rid of this 2. So it is a positive 2, and to get rid of it I need to use a negative 2. So I'm going to subtract 2 from both sides. That's going to give me a negative 3p left equals 12. And then finally, to get p all by itself, we need to separate it from the negative 3 that you're multiplying it by. So we will divide by a negative 3. Negative 3 divided by negative 3 is 1, which leaves us with 1p equals negative 4. And that's our answer. P is negative 4. If we were to take negative 4 and plug it back into the original equation, look what happens. We start with negative 3 times negative 4. That is positive 12. So we have a 2 plus a 12, which is 14. And 3 times 14 is 42. So it works out. Alright, but what if there's more than one variable, still the same variable, but it's on different sides of the equation? Let's take a look at how we would handle a little more complex problem. Alright, here we have an example of a problem, a linear equation, with variables on both sides. I have a y on the left, and I have a y on the right. With this type of an equation, you need to combine all of your variables on the same side. Now personally, I like to have my variables on the left side of the equation, so I'm going to start by getting this y over to this side. And since it is a positive y over here, I need to use the inverse operation to move it across the equal sign, so I'm going to subtract it. I will subtract a y from both sides. Y minus y is 0. 6y minus 5y, 6y minus y is 5y. And nothing else has changed. 5y plus 28 equals a negative 20 now. Just like before, our goal is to get y alone. We want our variable independent. We want it to be the only thing on its side. So, using the order of operations backwards, I need to get rid of any addition or subtraction affecting the y, and that is the plus 28, so we are going to subtract 28 first. That is going to give us a 5y equals negative 48. So now we have a 5y equals negative 48. And we can tell right away that this is not going to work out nicely for y, but that's okay. Not everything has to work out nicely. So we want to separate the y from the 5. It's multiplication, so we have to use division. We'll divide both sides by 5, and y ends up being negative 48 over 5, or you could think of it as negative 9 3/5. That's the same thing. All right, but now let's talk about inequalities. And how do inequalities change our problem? Here we have the inequality now, and it's an inequality because we don't have an equal sign. We have here a greater than or equal to sign. So we have x plus 8 is greater than or equal to 4x plus 17. Our goal in this problem is the same as the last problem, where we want all of our variables on the same side, because I have an x on the left side of the inequality and an x term on the right side of the inequality. Still, my preference is to keep my variables on the left side, so my first move is going to be get all of my variables together. Oops, and I don't want to subtract 3x, I want to subtract 4x. So we subtract 4x from both sides. 4x minus 4x is 0. X minus 4x is a negative 3x. Then I have the plus 8 greater than or equal to 17. Now, I need to get rid of everything around the x, so x is isolated. So I'm going to first get rid of the addition or subtraction affecting the x. So I'm going to subtract 8 from both sides. 8 minus 8 is 0. That leaves me with negative 3x is greater than or equal to 9. And now we will just separate the x from its coefficient. So we're going to divide by a negative 3. But since this is an inequality, we have to be mindful of something. In an inequality, when we divide by a negative number, our inequality sign flips. It changes direction. So right now it is greater than or equal to, but since I'm dividing by a negative 3, it is going to turn into a less than or equal sign. Dividing by a negative flips your inequality. And that gives us an answer of x is less than or equal to negative 3. And we've solved that inequality. Now we've covered pretty much everything we need to for this video, with one exception. Let's see what that exception is. That exception is when problems are dealing with identities or contradictions. Identities is when you end up equaling yourself. Contradictions is a false statement where your two sides of your equal sign do not match. And I have two examples down here to show what we mean by identities and contradictions. So let's look at the left side first. I have 3x plus 4x plus 5 equals 7x plus 5. So I'm going to simplify my left side by combining like terms. I get 3x plus 4x, that is 7x plus 5 equals 7x plus 5. And at this point, we should see that this is an identity. This is a very true statement. 7x plus 5 equals itself. So it's true. But if you don't notice that this is an identity at this point, well, we can go about our process as we have, get all of our variables on the same side. So I'm going to subtract 7x from both sides. 7x minus 7x is 0. 7x minus 7x is 0. And I'm left with 5 equals 5. Once again, that's an identity. This is true. And what happens in these problems for an identity is no matter what value you put in for x, it's going to work. You're going to get an answer no matter what value x is, whether it's 0, negative 3, or positive 500. It's going to work for both sides. So that is an identity. So I'll label that as identity. Now let's look at this side, which you can probably guess is the contradiction. On the right or left side, we need to do a little bit of distribution. So I have 8 times y and 8 times 7. That is 8y plus 56 equals, now we need to combine like terms on the right side. I have 6y plus 2y. That is 8y minus 8. And at this point, we hopefully will notice that something is off. This is not going to work out, because if we take a number, multiply it by 8, and add 56 to it, it's not going to equal that same number multiplied by 8 with 8 taken away. That's impossible. So right now, we should be able to notice that since we have the same coefficient on our variables, but different operations being performed on it, it's not going to work out to be the same. But if you don't notice that, go about trying to solve it. Get all of your variables on the same side. 8y minus 8y is 0, and that happens twice. And we're left with 56 equals negative 8. This is a false statement. 56 does not equal negative 8. And as a result, this is a contradiction. So nothing that we put in to our value for y in this problem will solve the equation. It has no solution. So there we go. We've talked about solving linear equations and inequalities, and we've also discussed identities and contradictions. Good luck with this topic.